Hi y'all. In this video I'm going to go through a method for factoring that I find very useful. It will work well on the problems we'll see, and it will actually also allow you to recognize when things are not factorable, which I find very, very valuable. Many of you have gone through factoring before, and that's one reason I would consider this video optional. As such, it'll be a little bit different format than the others, and if you want to just skip to the end to see the method in action, that's also fine. I'll try to put a note about where the overall method is in the video, in the title of the video. All right, so there's lots of ways to factor. I'm mostly going to go through one of them. You have additional problems in the worksheet that goes with this, so make sure you go through those if you have had problems with factoring before or if you wanted to look at another method. So the general idea with factoring is we're going to rewrite the original expression. So I'm not actually changing anything. It's just a different expression with the exact same values. Sometimes I'm factoring out a greatest common factor, like in this first expression where I factored out a 5. Or sometimes I'm rewriting it as a factor where I have a linear term times linear term to replace the original quadratic term. There are more things you can factor beyond this, but that's really the focus of what we'll be doing. So we're going to look at factoring out greatest common factors, factoring by grouping, factoring quadratics, and then some common forms to look for in factoring. I won't do much more than point these out, but sometimes using those common forms really can help you in seeing how to factor things. All right, so the first idea we're going to look at comes from the distributive property of multiplication over addition, which is a handful to say, but it's very, very useful. It's the idea that if you have A times the quantity B plus C, the result of that is A times, or AB plus AC. To see this, I like this little visual. So if you have a box that's made up of two rectangles, you can see the area of one of the rectangles is AB, and the area of the other rectangle is BC. So the total area of the box should be AB plus AC. I'm sorry, AB plus BC. But if you notice along the top, the total length of the box is B plus C, which means that if I take the width times the length up here, the overall result would be A times the quantity B plus C. So those two amounts have to be the same. But again, this property undergrids everything we're doing with factoring. So typically when we go from the A times the quantity B plus C side and we multiply that out, we're going to call that distributing. Going the opposite direction, we're going to call that factoring. I will also point out, like the A, through a variety of different properties, we can have it B times A and C times A, and we can still pull the A out to the front. And I will often do it in that order. So that's something we'll see. In general, the hard part to all of these problems will be figuring out what A is. So that's kind of the deal. It's all about finding your A. And these examples will look at factoring out a greatest common factor, and in the last example, we will look at factoring by grouping. So when we're going to factor out a greatest common factor, we're going to carefully examine each of the terms, and in looking at this 5x cubed and the 15x squared, hopefully you'll notice they each have a 5 in common, and the highest x that they both have is x to the second power, so I'm going to factor out a 5x squared. So when you do that, you want to notice a few things about this, that this is now the a term, the 5x squared is, and the b term is going to be whatever I get when I divide AB, the 5x cubed, by a. So doing that, I'm left with this x here, and that's one way to find this x. So sometimes this is fairly straightforward, and sometimes it requires more work. But you want to bear in mind that to find this term, you can always take the AB, the 5x cubed, and divide it by a. I'll also point out that inside the parentheses, I do have two terms here. I started with two terms. You're going to have two terms left inside the parentheses. So when I factor out my greatest common factor on part 2, I'm going to be left with three terms inside the parentheses. So examining carefully the 14x to the 7th, 6x to the 5th, and the 18x, I should notice they all have a 2 and an x in common. So my a will be 2x, and then I'll see my three terms inside the parentheses. On the third one, we're going to notice there are an even number of terms. In this case, 4. And when there's an even number of terms, we're often going to want to try to factor by grouping. So here, I'm going to break this into two separate pieces, the 3a minus 12 and the 5ab minus 20b, and see if I can factor a common term out of each of them separately. So for the first two terms, I have a 3 in common. For the second two terms, I have a 5b in common. So separately factoring those out, you now nicely notice that each of them has an a minus 4 term. So with that, that's going to be my A. So this is kind of using that last expression we had from the previous slide. So my A is the A minus 4. I'm going to bring that out to the front. And what I would be left with, if I get rid of this A minus 4 from each of the terms, is a 3 and a 5B. And that's going to be what's left inside the parentheses. So my overall result here is A minus 4 times the quantity 3 plus 5B. So that's going to be something I will use in my method for factoring trinomials. But let's look at another example where we're going to factor by grouping. So this 2x squared plus 10x plus x plus 5. I have the 4 terms here. So looking at the first two, they have a 2x in common. And the second two, the only thing I can really factor out there is a 1. So doing that, you're going to notice again we have this x plus 5 in common. Or it's not the same thing we had before, but we have a term in common. And that I will pull out to the front. That's my A, and I'm left with the 2x plus 1 on the inside. Okay, so my overall result is going to be x plus 5 times the quantity 2x plus 1. But if you look at this original problem, we don't normally write 10x plus 1x in an expression like this. We normally write 11x. Okay, so the trick to this method is figuring out a way so that we can break up 11x in such a way that the factoring will work. To do that, I'm first going to point out a slightly easier problem. If I look at anything of the form x plus s times x plus t, and I distribute the x to the x and the t, and then the s to the x and the t, I can break that up this way. Those middle two terms have an x in common, so I can factor that x out and write this as s plus t times x. Okay, so what this kind of demonstrates, and this would be true even if I had a different value out in front of the x squared, is that the middle term here, that's normally my b term in ax squared plus bx plus c, is the sum of two numbers, s plus t, while this last term is the product of two numbers, s times t. And that's going to kind of form the basis of what we're doing. We're going to be looking for two numbers that add up to a certain number, and at the same time multiply together to be another number that we'll know. So going through all of what the process is going to look like when we get there, we're going to see here, if I start with the 3x squared minus 10x plus 8, and I break up the negative 10x plus into two terms, negative 6x minus 4x, and then I factor by grouping, we're going to notice that when I get to my overall results down here, I have an x minus 2 in common. And with that, I can factor out that x minus 2. So I really want to stress that the x minus 2 is there. Doing that, we're going to see the x minus 2 comes out to the front. So my overall result in this factoring is that I get x minus 2 times 3x minus 4 with a little stuff disappearing up there. And that's the correct way to factor this. I will add here, I will not be quite a good enough person to go through this, but when you're having problems with factoring, one of the quickest ways to get better is to practice by distributing out your answer. So FOIL out the final answer is what sometimes we call this, but make sure these things are working correctly. But this is where we're going to go. The trick to this is figuring out that negative 6x minus 4x was the right way to break up the negative 10. And we'll go through that method in just a second, but I want to go through one more example of what all this will look like. So in this problem, we're breaking up the negative 7x as negative 3x minus 4x. Then I'm going to factor by grouping, again, by breaking into two parts. We're going to see we have an x minus 3 in common, and we're going to take that x minus 3 and bring it out to the front. All right, so let's go through the whole problem, including figuring out the middle two numbers and how to break that up. So in our example here, we're asked to factor 4x squared minus 7x minus 15. So to do that, I need to break up the negative 7x up into two different terms, and let's figure out how to do that. So we're going to take the a and the c and multiply those. That's the 4 times negative 15, and that'll give us negative 60. That's what we need to find two numbers to multiply together to be, and they need to add up to be the b term to be the negative 7. So I'm looking for two numbers that multiply together to be negative 60 and add up to be negative 7. So for this method, all you really need to do is to know how to factor negative 60. Though to do that, we want to pay attention to the sum being negative. So since I'm taking a product of two numbers that result in a negative, that means one's positive and one is negative, because to have that multiplication work, that's what we need. And since I'm adding them up and getting a negative result, that means the one with the higher absolute value, the bigger one, is going to be the negative one. So I'm looking for two numbers kind of like 1 and negative 60. And I didn't just randomly choose those. I'm always going to start with 1 or -1 as one of the terms I'm factoring out. And then I'm going to take that 1 plus -60, add them up, and I get -59. But I put a little X there because that didn't work. That's not the number I'm looking for. But I'm going to keep going. So the next number that's bigger than 1 that divides into 60 is 2. So dividing 60 by 2 gives me -30. Then adding those up, I get -28. That's still not right. And I'm just going to keep going. And I'm going to keep going down my list until I find one that multiplies together to be -7. Okay, so I'll point out, if I went one further to 6 and -10, those are all of the two ways I can multiply together to get two numbers to get -60 that add up to be a negative numbers with whole numbers. If B had not been on this list of numbers, then this would not factor over the rational numbers. That is, it's not going to factor in the nice way we want with whole numbers. So the -7 did work though, so that's how I'm going to break up the -7, the B term, as 5x plus 5x minus 12x. All right, so that's what we just saw. Again, I'm going to break up the -7x as plus 5x minus 12x. Now I'm going to factor by grouping. So I'm going to look at the first two terms together and see they have an x in common. All right, so with that, I then need to factor the last two terms. And I'm going to tell you, my experience suggests very strongly, it's actually quite a bit easier if you recognize that if I was able to find the two numbers to break up the -7, as we did on the previous page, then I have to have a 4x plus 5 in common in these last two terms. So I'm going to slightly change the question from looking for a greatest common factor to saying, what times 4x is -12x? And I'm pretty sure that's -3. And I can check that that was correct by saying, is -3 times plus 5 -15? And that looks right. So this is what I wanted. I can then notice I have a 4x and plus 5 in common between those two terms, as I knew I had to, because I was able to break this -7x up, I will be able to factor this. Taking that 4x plus 5 out to the front, I've got my overall result. So I am done. So that's the process all put together. And that's how I would recommend you factor if you've had problems with it in the past. So in the notes, I briefly discussed factoring by guessing and checking, which as far as I can tell is the only way I ever learned in school, which worked fine if you were good at it and horribly if you couldn't get it. So with this, I'm going to plug actually checking your answers, but this is what a fully worked out problem would look like. And again, this is not necessarily the fastest method, but it will always work and nicely tell you when it doesn't. All right, to facilitate this, I'm going to go through another problem a little faster, but I want to show you how you can use your calculator or Excel to help you make these lists. All right, so on my calculator, and this is typed in the notes toward the end of this sheet, but I'm not going to reiterate that. On my calculator, I'm going to take the product, the -120, and I'm going to put it in on the y equals. Sorry, I didn't show you that part. So normally where we graph things, I'm not going to graph it, but that's where this will go, and divide it by x. And then I'm going to do something kind of weird. I'm going to use the vars button, and I'm going to use y vars. And I'm going to click the first value and the first one. So y2 will now be the result that I got on y1, but I'm going to add x to that. Okay, so this is going to give me a list of numbers that I'm dividing -120 by, and then I'm going to add the two numbers up. So this is the same process I was doing over here. Okay, so I'm trying to find out where this sum is 2, so I'm going to look at a table of values, and I'm going to point out that if I look, so the y2 is my sum, so I'm trying to make that into a positive 37, and I'll point out these are going in the wrong direction because they're all negative, so I need to go up, and you can see over here that y2 is a positive 37 when one of my values is -3 and the other is 40. So I can actually use my calculator to help me make this list, so that's nice. On Excel, I'll move it over here where we can see it. I could make my product here, and I can have a sum here, and the product was -120. I could actually have Excel work that out as well. And I'm going to take the numbered list over here, and I'll just make a list of numbers by adding 1. And then take these numbers and divide -120 by that. So Control C, Control V. And I'll point out this is kind of a fail because I'm going the wrong direction. But I did want to add these up. And I'm getting the wrong sign. I did one thing wrong here. Let me hold on real quick. Each time I was supposed to be dividing by -120. So I would need to use $signs in Excel to keep it fixed at that place. All right. So my list should look B4. Let's try it one more time. $signs were the right idea, but it was C3 is where the -120 is. JK. All right. So this is now making my list correct. I should have, however, started with a -1 and gone down by 1 from there, because I wanted those values to be negative, because that's how those numbers worked out. It looks like the calculator might have been a little better move here, but Excel would for sure make this list doable as well. So you can facilitate that if you're having problems with it by hand, and this will get better fairly quickly. From there, this is saying I'm going to break up the the positive 37 as -3 plus 40. And then I can factor by grouping, taking these first two terms. I have a 3x in common. And I see I'm multiplying that by 2x plus 1. So to find the 20 here, I'm going to take 40x and divide it by 2x, giving me the 20. And then I can factor the 2x plus 1 out to the front and be left with the 3x plus 40. All right, so again, I like this method in particular because it always works. That's a nice approach to have, is something that always works. It also will tell you when the function is not factorable, which is very useful. So sometimes we're trying to factor something that won't. This will make that a little easier to see. Please go through the notes. If you have other questions, let me know. And I will point out I do have these on the notes there, but there are many other good ways to factor. I am ambivalent about how you factor so long as you have a way that works for you. So there are a couple listed there, and you can check those out if you want. Best of luck with this. As always, reach out to your instructor if you have any questions.